Now we will move to our next topic, that is how to simplify the given complex block diagram and to find its transfer function with the help of certain rules. So let's discuss our first rule, that is when the blocks are in series. So here there is a case. First block has gain of G1 and second block has gain of G2, and here it is the input x1, and here at this point this value is x1 into Z1 after multiplying it by Z1, and here it becomes, after multiplying it by G2, it becomes x1, G2 and G2. This block can be described by this equivalent diagram with a single block which has gain of G1, G2. Here input is x1 and the output is x1, G1, G2. So the equivalent means the input and output should remain the same. So we have seen if two blocks are in series, we have to just take the product of them. Now we will discuss the second rule, that is when the two blocks are in parallel. So suppose one block has gain of G1 and we have here input x1, and another block which is in parallel to G1, that is G2, and here there is a summing amplifier. This block can be represented by this equivalent diagram where we have the gain of G1 plus G2, because here it becomes here x1 G1 at this point, and this point is x1 G2. So here it becomes x1 G1 plus x1 G2, that is x1 G1 plus G2. Similarly, here in this equivalent diagram we can see input is x1 and the output is x1 G1 plus G2. Now we will see the third case where the two blocks are in parallel, but here there is a subtraction sign. So see, this min is G1, here it is x1, and here it is G2, and I have here plus sign, I have here minus sign. So the equivalent, the output will be, this point will be x1 G2 and this point will be the x1 G1. So the answer will be, the output will be the x1 G1 plus and x1 G1 minus x1 G2, because here it is minus sign. So it will become x1 G1 minus G2. This can be represented by this equivalent form where we have x1 here and the gain is G1 minus G2, and the output will be the x1 G1 minus G2. So we have seen here when the blocks are in series, when the blocks are in parallel, and when it is in the sign is plus here, and when the sign is here minus. Suppose we have given a complex block diagram and we have here gain G1, here this arrow here, and we have given this type of system. This one is plus and this one is minus, and we have to find the output here, and we have given here input as x1. So in this case we can, the gain here we can make it 1, because this line is multiplying this x1 by 1. So we have written here 1, and as they are in parallel, and here it is plus sign, here it is minus sign, so I can write here x1 g1 minus 1. The gain of this system is x1 g1 minus 1. So you should also see the arrow side, the sign of this, the direction of this arrow, and if this arrow, the direction of this arrow is in the reverse direction, that is, if it is in this direction, then it will be a feedback loop. Then the equivalent output will be the different. But here, as we are considering these two blocks are in parallel, so here the sign of this arrow is in this direction, the direction of this arrow is in this direction, and this arrow is in this direction. So equivalent will be the x1 g1 minus 1. Similarly, if here it is x1 here and the direction is here, here it is g1, and we have given here this summing amplifier, here it is sign is plus here, so I will make it right here 1, and I will write its output will be x1 g1 plus 1. Now moving on to our fourth rule, that is moving a summing point after a block. So suppose I have given a condition where input is x1, here is a summing amplifier, and here this is plus minus point here, and here gain is G, and here I have another input x2. So here it will be x1 minus x2 or x1 plus x2, depend on here it is, if it is here plus sign or minus sign. So I will write here x1 plus minus x2, and here output will be G into x1 plus minus x2. Now to simplify a block diagram, I want to place this block here. Before this, after I have to place this gain block before this summing amplifier. So what I will do, so I have to keep one thing in mind, that input x1 should be the same, this takeoff point value, this input x2 value should also be the same, and this output should also be the same. So what I will do here, I will place this G here, so it will be x1 G, then here it's the summing amplifier here, plus sign. So corresponding to this, I will get here x1G, and what I will do, I will put x2 here, and I will put the copy of this gain here G, and I will give to this summing amplifier, here it is plus sign, minus, plus minus. So here I will get the Gx1, here it is Gx1 as you know here, and here it is Gx2. So Gx1 plus minus Gx2, it will be G, then x1 plus minus x2. So we have learned here important trick. So if we have to place the summing amplifier after this block, so what I have to do, I have to copy this, place this G here, and I have to copy this value of G to this input, x2 input also, so that here you can see the input is here x1, here is also input is x2 here at this point, and the final output is here G x1 plus minus x2. So moving on to our fifth rule. Suppose here now I have given a condition where I have this block ahead of the summing amplifier. So here it is summing amplifier plus sign, and this here plus minus sign here, and here is my input, another input x2. So, and I have to place this gain block here. So let's analyze this equation. Here at this point the value is x1g, and here it is x1g, and here value is x2. Here it is plus minus sign, so it will be x1g plus minus x2. Now I will make an equivalent diagram. With this G block I will place ahead of this summing amplifier. So, and provided the input and output, input x1 and x2, and this output x1 g plus minus x2 should be the same. So what I will do here, I will make summing amplifier here, plus sign here, and here I will place this gain as G. So I will get here x1g corresponding to this point. Now I have another input here x2, but the problem is here I am getting x1g, and here I am getting gx2 plus minus gx2, but it will be different from this output. So what I will do, I will make another block, I will place another block which its value will be 1 by g. So what will happen, it will become x2 by g, and now after multiplying by this g factor it will become x2, and finally I will get here plus minus x2. So we have seen here, if we want to place a gain block ahead of this G, so we have to place another copy of gain block which value is 1 by G at another input x2, so that we will get the same output as we have earlier, x1g plus minus x2 and x1g plus minus x2. Now we'll move to our sixth rule, where we have given a takeoff point and a gain block, and we have to shift this takeoff point. So here we have given this takeoff point. Takeoff point, you can consider it as a something which is we have copied here. So if its value is x1 here, its value is x1 here at this point also, and here the output is x1g. So I want to make this, I want to place this takeoff point ahead of this gain block. So what I will do, x1 then g, and I am placing this block here. So I will get here output as x1g, but the condition is the value of the takeoff point should also be the same. But here the value is x1g, so I am getting the value of takeoff point as x1g, but it should be x1. So what I will do, I will simply put a gain block which has the value of 1 by z, so that I will get here again the final value of this takeoff point as x1 only, because here it is x1g, it is getting multiplied by 1 by g, and I am getting here x1. So now we will see another twist in this equations. Suppose I have given a takeoff point after this gain block, and I have to place this block before this, I have to place this takeoff point before the gain block. So here we have x1 here, and we have here g, and we have here output as x1g, and the takeoff point is here. So here the value of this takeoff point is x1g, and I have to place this takeoff point here, that is before the block. So what I will do here, x1g, its output will be the x1g only, and I am placing here takeoff point here, but here value will be x1 and the desired value is x1g. So what I will do, I simply put a gain block which has value of g, so that I will get the value of takeoff point as x1g, similar to this point. Now there is one more another very important rule, that is eliminating a feedback loop. So suppose I have given, and there are two types of feedback loop. One is positive feedback loop and another is negative feedback loop. So here, if it is x1 input is there and there is one summing amplifier is there, this plus sign, and suppose here it is minus sign, and I'm there here it is a gain block G, and here I have feedback loop which has the value of H. So the total value, the output of the system, or it can be equivalently written as x1 G1 plus GH. So if I have this type of feedback loop, negative feedback loop, where I have a gain block G, feedback value H, it can be equivalently replaced by this block which has the gain of G1 plus GH. Please note the sign here. If it is minus here, it is here plus. But if it is plus here, plus, and here it is, the value of feedback value is H again, and here the value of gain is G, and output is x2 here. So its value will be x1 x2 G1 minus GH. So keep in mind here, if it is plus here, it will be minus here, and if it is minus here, it will be a plus here. And if here suppose plus minus, then here I will write here G1 minus plus GH. So opposite to plus, if it is plus, it is negative, if it is negative, it is plus. So this is a very important rule. Now we will discuss the special case of the feedback loop. Here we have unity feedback gain. So we have this line here. So its value is 1. So that's mean here x2 is the value is here x2. Here also the value is x2. So this thing is multiplying by 1. So it is a unity feedback and the negative feedback. So here the output will be 1 G, the transfer function will be G1 plus GH. So the value of H is 1, so I can write here 1 plus G. Similarly, if I have here plus sign, suppose plus sign, then its output will be G1 minus GH. So minus H is 1, so 1 minus G. So if it is plus sign here, I will write G1 plus G. If it is minus sign here, I will write if it is plus sign, I will write 1 minus G. And if it is minus sign, I will write here 1 plus G. And if here it is plus minus sign, so here I will write here G1 minus plus G. So plus minus minus plus. So we have seen here the special case of a unity feedback system. So we will look into one more exercise. Suppose here we have three blocks, G1, G2 and G3, and suppose the takeoff point is behind this block G2, and we have to place this takeoff point ahead of this block G2. So here input is x1, the output is here x2. So here its value is x1 G1. So first I will see the case where I have to place it ahead. So here x1 G1 G2, and here it is G3 here, and I am placing this takeoff point here. So but the thing is, here its value x1 G1, and the thing is here its value is x1 G1, and it is getting multiplied by x1 G1 G2. So this fellow is getting G2 as an extra factor. To remove this extra factor G2, what I will do? I will place a 1 by G2. So it will be, here it is x1 G1, here it is x1 G1 G2, and here it will be x1 G1 multiplied by this 1 by G1, 1 by G2. So here I will get x1 G1, which is the same as here, the original case x1 G1. And now we will see the another case where we have to place, if it is we have given condition where this takeoff point is, suppose I have to place this block, this takeoff point behind this block G1. So its value is x1 G1, and I am placing it here before this block. So here it is G1 here it is x1, here it is G2 here. So originally it is at this position, it is x1 G1, and I am placing this takeoff point here. But here the original value is x1 G1, so it is getting multiplied by G1 factor. But here it is not getting multiplied by G1 factor, here it is x1 only. So what I will do? I will place a G1 here, G1. So it will be again x1 G1, which is similar to here in this case x1 G1. So we have seen, if we have to place this takeoff point ahead of the given block G2, then we have to place another block which has value 1 by G2. And if we are placing this takeoff point before this block which has value G1, then we have to multiply it by G1. So that is, if it is we are placing it takeoff point ahead, then we have to divide, and if we are making it behind the block, then we have to multiply. So A 1 by G behind G.